Hey, what's up guys? I'm the Resonator. Today, we're gonna talk about basic electricities. You're gonna know what actually is electricity and what is the source, what are the insulators, what are the conductors, what is DC, what is AC, and some terminologies like voltage, current, and resistance. Yeah, let's get started, shall we? So, firstly, we're gonna talk about what is electricity. You know the structure of an atom? You have a nucleus here. In the nucleus, you have some positive charge. And outside the nucleus, you got the electron cloud with some negative charges. So for example, this is lithium. Lithium has 3 electrons and the outer shell has 1. Yeah, it's pretty unstable. It wants to lose that electron, so it becomes a conductor. Another example of conductor that we commonly use is a copper. The metal in the wire, is mostly copper. So copper is a group 11 metal. So it has 1 outer shell electron, which is very unstable. It wants to lose it. So if you have a substance and the substance, this one has negative charges, this one has positive charges. What I mean with negative and positive charge, so basically negative charge substance, it is negative charge. Yeah, correct. That means it has its electrons are more than its protons in order to make it negative. Yeah, and for that one, you probably know it. The protons doesn't change, otherwise it's gonna be like fusion reaction. It's gonna be not be a chemical reaction. So that means its electrons are less than the number of protons in the substance. And if you actually join these two things, connect it with a piece of copper, and these two substances, imagine they're connected. So basically, the free electrons in the copper are all just attracted, because different charges are attracting each other, and although it's electronically neutral for the pure copper, its electron is pretty unstable, and the electron, it wants to lose it, and the electrons is negative charge. The negative charge is attracted by the positive charge, so it tends to goes there, and it goes back to the negative end because it has lots of electrons going there, and it goes back. Yeah, it's a loop, isn't it? Bam! You got the circuit. That's a simple circuit, the simplest circuit. So what happened is, this bit is actually the source, the power source. It provides the circuit the power. This is a DC source, because probably your science teacher would say, oh, electricity is the flow of electrons, but in in electric engineer, it's not like that. Your science teacher might say, the electrons come out from the negative end of the battery, passes through the whole circuit, and goes back to the positive end. Yeah, it is correct, but you don't say that in EE, you know? It's just silly. The definition of electricity is the flow of positive charge. This idea is from Benjamin Franklin. Yeah, the dude on the US note. That's him. So what he did is he fly the kite in a thunder weather, and for somehow he get this theory. He says electrons come out from the positive end and goes to the negative end. Well, he made that theory, and people at that time say, it's from Benjamin Franklin. We should trust that. He's authoritative. And yeah, later on, people realized, no, electrons actually come from the negative end. And yeah, Benjamin Franklin just failed that test. He has literally from positive end or negative end, 50-50 chance, and he's wrong. But people start to realize, why don't we just stick with it? So we're gonna change the definition of electricity to the flow of positive charges. I just missed an S there. As you can see, the electrons flow from the negative end to the positive end. It's like that. And if the electrons move out, say this used to be neutral, and now one electron move out, it becomes there. So this takes this bit negative charge, this bit positive charge. Isn't it correct? So you can kind of say the flow of electron is also the flow of positive charge. So the flow of positive charge is gonna come out from the positive end, across the whole circuit, back to the negative end. This is actually done by electrical field force. Yeah, electrical field force. That's what it did. So the negative end, so the electrical field force is applied on the negative end. It attracts the positive charges on the positive end. Yeah, like that. And the positive charges should come back to it. Otherwise it running out of charges. It becomes electrical neutral, doesn't it? It's not gonna work. So how does this positive charges coming from this stinky negative end towards the positive end? The answer is the power source. This is done by the power source of the source. That's why it is called source, because it applies power. It actually counters the power source counters electrical field force in order to attract these positive charges at the negative end back to the positive end, and do the same thing again, rotating, looping. Yeah, and you got it. That is basically what electricity is. And you know, the aim of using electricity is to transform electricity into the energy we can use. So for example, the light transforms electricity into light energy that we use to light our room. So a circuit must have at least 3 components. The first one is the source. In this case, it's the battery. It can be a signal, it can be the power from the power point, the 240 volts AC. It must have load. Actually, load. It's pronounced as load. I'm a bit dumb, yeah. What is load? you connect the power source to your PC. Your PC is a load, and you have to have the connections between the components. Most of the time the connection is wire. So you have a little plug that's gonna be your source, and the wire that's gonna be the connection, and our PC that's gonna be your load. That's just a circuit. How simple is that? Yeah. Let's move to the next concept. So, different materials has different level of conducting electricity. If a material is pretty good at conducting electricity, it is called the conductor. Obviously, it conducts, so why not? Examples of conductors are iron, copper, almost all the metal actually. And in the opposite, we got insulator, which barely, it's hard to lose electrons from it. Conductors are good, its electrons is easy to lose, but in the inductors, its electrons are very hard to lose. So examples include air and wood and rubber, that's insulators. Actually, conductors are substances with small resistance. The idea of resistance will be taught later. Insulator, big resistance. Okay, let's move to the next concept. We have a voltage. I think you've got, even though you don't understand electricity, you've heard about this idea a lot of time. They say, oh, in Australia, the voltage of the power source sent to our home is 240 volts. That is the voltage. The unit of voltage is volt, which simply you write as V. But the symbol of voltage, like if you say, it's like another way to say voltage is a U. So you can say the unit of U is V. Yeah, it's the same as the unit of voltage is volt. What voltage is? Imagine this is a battery. This is the sign of a battery. Okay? The symbol of a battery. Like that, that's a wire. Yeah. Imagine this is a positive end, positive terminal, negative terminal. So, how high it is? I mean, in this case, in the voltage, we're talking about the source. Well, the source of the voltage is how big its electric field force is. So like, pretty much you can understand it as how many forces can you do to push the electrons. So for example, this is a 3 volt battery. So you can, that means this bit is 0, this bit is 3 volt, and yeah, the positive charge comes out from the positive end, goes back to the negative end, and goes back to the positive end by power force. That's what the voltage on the battery is. Now we're gonna move to the voltage, the actual definition of voltage. The actual definition of voltage is the voltage drop, the difference of voltage drops. And you're probably gonna ask, what is a voltage drop? Like, I mean, voltage drop. Now it's voltage point, not voltage drop. I'm just so dumb. Voltage drop is the same as voltage. I'm just so dumb. Sorry for that. This is a resistor. Resistors have resistance. Resistance is how good can it conduct electricity. That's basically what resistance is. Its unit is called ohm, and it's written as I don't know, it's a Greek letter or something, but it's definitely not an English letter. It's like that. Yeah, that's what the ohm is. And the symbol of resistance is R. Just like U for voltage. So the resistor, so let's say this is 100 ohm. This is not the big resistor, and this is 5 volts probably. Let's go. See? Probably I would just put 2 of them. Voltage point means the voltage to a specific point on the circuit. It's voltage to the ground. The ground is normally just the negative end. This is ground is. That's what normal people do. If you're pretty weird and you think, oh, I'm not gonna ground the negative end, I'm gonna ground these. That means negative end is now not 0 volts. Anything who's grounded, grounded is not the actual grounding, like you put wires into the earth. That's not what grounding is. It's just a fake concept for people to analyze circuit, to interpret it. It's not useful in like the actual circuit. The actual circuit doesn't work like that. It's just easier for you to analyze, okay? Basically, grounding means you set this point 0 volt, and all the other voltage on C, the voltage drop of this specific point is the voltage from this to this voltage. What is it? And the voltage drop is the same. So the voltage drop, what's the voltage drop of this point? What's the voltage drop of this resistor? That's what people usually say. The voltage drop of a resistor, the voltage drop of a circuit. Yeah. And these resistors consumes electricity. So it drops the voltage or it drops the current. One of them has to be reduced. Otherwise, energy can't be summoned just for no reason. It has to be the same. That's what voltage is. Now, we move to current. Current is how many electrons are flowed in a surface. So, for example, this is a wire, and its surface is like that. How many electrons are flowed in this surface in 1 second? If it's this amount of electrons, then that means its current is 1 amp. I don't know if I spell it correctly or not. So it's current, its symbol is A. Now its unit is A. Amp, A. Current, its symbol for current is I. Yeah. And the resistors also stops. It makes the electrons, or yeah, actually positive charges, hard to flow through, you know? That's what the resistor does. So if I have this circuit, I have a resistor there. So literally, there are two ways to write a resistor. It depends which way you prefer. You can either write a resistor like that, like a triangle, or where like a zip attached to wire. That's how you write the symbol of resistor on the electric diagram. This actually makes the electrons hard to flow. So yeah, that's what current means. And tomorrow, not tomorrow, next week, we're gonna talk about Ohm's law, which tells you about the relationship between voltage, current, and resistance. Yeah, and we're gonna do some experiments and some questions. Yeah. So if you like this video, please subscribe me. It helps me a lot. Thank you.